Isaac Newton and the Laws That Moved the Universe, 1687. The wind whispered through the apple trees of Woolsthorpe Manor, and a young man sat beneath their branches, lost in thought. His name was Isaac Newton, and though the story of the falling apple may be legend, what grew from that moment was very real, a revolution in how humanity understood the universe itself. It was the mid-17th century, a time when the world was still emerging from centuries of superstition. The telescope had shown new worlds, Galileo had been silenced, and Descartes had written, "I think, therefore I am." Yet the heavens still seemed governed by mystery. What force held the planets in their paths? What law guided both the fall of a stone and the motion of the stars? Newton sought the answers, not through faith or philosophy, but through reason, mathematics, and experiment. When the Great Plague swept through London in 1665, the young scholar fled Cambridge University and returned home. In isolation, while the world outside descended into fear, Newton entered a private age of discovery. He studied light and optics, grinding his own lenses and splitting sunlight into rainbows. He explored motion by rolling balls down inclined planes and timing their fall. And he asked the question that would change everything. Does the same force that pulls an apple to the ground also guide the moon around the Earth? 2 decades later, in 1687, Newton published a book that would reshape all of science, Philosophiae Naturalis Principia Mathematica, known simply as the Principia. In its pages, written in Latin, he revealed 3 laws of motion and a single, unifying force, universal gravitation. Every object in the universe, he declared, attracts every other object with a force proportional to their masses and inversely proportional to the square of their distance. The same law that governed a falling apple also governed the orbits of the planets. The cosmos was no longer chaos. It was clockwork, elegant and precise. The Principia was more than a book. It was a revelation. It turned the heavens from mystery into mathematics. The language of God, Newton showed, could be written in numbers, geometry, and reason. Across Europe, thinkers hailed him as the architect of the universe. Edmund Halley, who had funded the Principia, wrote that Newton had revealed the harmony of the spheres. The Royal Society called him a genius touched by divine inspiration. Even kings and priests bowed to his intellect. But Newton himself remained humble, almost reclusive. "I do not know what I may appear to the world," he once wrote, "but to myself, I seem to have been only like a boy playing on the seashore, finding a smoother pebble or a prettier shell, while the great ocean of truth lay all undiscovered before me." When Newton died in 1727, he was buried in Westminster Abbey, among kings and poets. Upon his tomb were carved the words, "Let mortals rejoice that there has existed such, and so great an ornament of the human race." His laws would stand unchallenged for more than 2 centuries, until Einstein bent them with relativity, and quantum physics shattered them further. Yet even today, rockets still fly and planets still move by Newton's equations. His work did more than explain motion, it defined the very method of science, to seek truth not in authority, but in observation and proof. The universe, once ruled by mystery, now danced to the rhythm of mathematics. And in that rhythm, mankind found not only knowledge, but its place among the stars.